to this online demo for Keithley's SignalMeister 2.0 Waveform Creation Software. SignalMeister Waveform Creation Software is a powerful RF development tool with the next-generation performance and usability. SignalMeister 2.0 features a new object-oriented graphic user interface and is the only waveform creation software on the market that uses a click-and-drag object-based approach, allowing RF engineers to intuitively create basic and complex waveforms using graphical objects. This object-oriented GUI is optimized for MIMO signals and allows users to visually create a dramatically expanded range of test waveforms. SignalMeister 2.0 enables the creation of an entire range of signals in accordance with WiMAX and the wireless LAN connectivity standards and the 3GPP and the 3GPP2 cellular standards. Generating a signal with the SignalMeister software involves three simple steps. The first one, creating the signal with its associated properties and adding distortion. The second, generating an arbitrary waveform file. The third one, download the file to the instruments. Now we'll go through some basics of the GUI and navigation. The SignalMeister GUI has four main areas. The first one is toolbox, contains extensive library of signals, distortion, file, and instrument types. The project's work area is where the signal will be created, edited, generated, and downloaded. You can zoom in or pan around the work area using the pan and zoom area. The last one, the signal creation status and the messages are displayed in the status area. The Actions pull-down menus allow you to load and save projects, create or create new project worksheets. The toolbar can be configured to allow execution of the actions you use most frequently. Step 1. Creating the signal with associated properties and adding distortion. Select the signal from the toolbox by pressing the appropriate tab, then dragging and dropping the chosen signal default over into the projects area. For example, you can select the WiMAX tab, then drag and drop the DL 10 MHz 1024 FFT icon. You can zoom in on the signal using the pan and zoom window. Double-click on the signal icon in the projects allow you to edit the signal's properties. In the WiMAX example, there are three tabs: General, DL subframe, and UL subframe. With the General tab, you can adjust the specific properties such as the number of subcarriers, bandwidth, and guard intervals. You can also specify the frame size. Define the type of subframe you want to generate by how many OFDM symbols you want to have in each frame. The graphic at the bottom of the window shows the frame structure you are defining. By increasing the bandwidth, you can see each frame has the capacity for more OFDM symbols. By increasing the actual number of symbols on the right-hand side of the window, you can fill out the DL or UL portion of the frame. Click on the DL subframe tab. This brings up a new window. Now you can modify the DL subframe. By right-clicking on the downlink subframe boxes or zones, you can delete zones. By left-clicking and dragging on the empty boxes, you can add additional zones. Also, by left-clicking on any existing zone, you will associate this zone with its symbol versus a subchannel map. Below the downlink subframe graphic is a vertical table, the symbol subchannel map for the highlighted zone on the downlink subframe map. Left-click and drag on any empty cells in the map to define the burst for those cells. The burst parameters for those cells will be shown on the right. Right-click on any existing burst to change the modulation, rate, and coding, or delete the burst. Once the signal is defined, press OK. If you want to add distortion to the signal, find the Operation tab in the toolbox. The following operations can be used to distort the signal: AWGN, invert Q, IQ gain imbalance, IQ offset, or 2x2 MIMO channel distortion, or 4x4 MIMO channel distortion. Select distortion. For example, invert Q and drag it over into the project's work area. By double-clicking on the icon, you can adjust the properties of distortion. You can now connect the two elements by clicking on the double-ended arrow in the toolbar, then clicking on each element you wish to connect. Step 2. Generating an arbitrary waveform file. Now that you have created a signal, you can define the file into which you want to save it. From the Files menu in the toolbox, you can choose the Keithley ARP file and also create a WiMAX map file, which the analyzer requires to do demodulation. Drag and drop the two icons across to the projects area. Then connect them to the signal. By double-clicking on the icon, you can change the default file name of the ARP file. In many cases, this will be all that is needed to demonstrate the SignalMeister capability. The file can be saved in the PC by indicating the desired directory in the file name of the ARP file, and then clicking on the project in the Actions list. Then click on Build All. This step generates the actual file and places it in the location you specified, and is indicated by the icons turning green. The file can then be transferred into the instrument by USB memory stick or via GPIB or LAN. If the instrument is right connected to the PC used for this demo, follow the next steps. Step 3. Downloading the file to the instruments. The final step is defining the instruments to which you want to download the signal. Select the Signal Generator tab in the toolbox and drag and drop the appropriate instrument into the project's work area. For example, a Keithley Model 2910 vector signal generator. By double-clicking on the icon, you can define the connection properties. If you are connected via LAN, you can add instrument's Ethernet address by pressing the Config button. You can find the instrument's address by pressing Menu, then Ethernet Settings on the instruments. You can test the link by selecting the LXI Web Interface tab by clicking Start LXI Web Interface. This will access the web server within the instruments and display the instrument's welcome page. Close or minimize this window, then press OK on the instrument dialog window. Select Project and Load All, and the software will build the appropriate signal. Download it to the instruments and load it into the ARP. Download All will only build the signal and download it into the instrument, but not load it into the ARP. The file can only be loaded into the ARP if the instrument has appropriate license. This screen illustrates a complete WiMAX signal. Two signals are generated, one with Q inversion and one with no distortion. Note that a WiMAX map file is created and downloaded into the analyzer to aid in the analysis of the signal. From SISO to MIMO. The SignalMeister software includes a number of pre-configured MIMO elements. For example, you can create a new worksheet by selecting Add Worksheet from the Worksheets menu. From the toolbox area, select WLAN tab. Drag and drop a signal element over into the projects area. For example, the AO2.11n4x MIMO signal. You can add noise or channel distortion by selecting the appropriate signal modification from the Operations tab. The following figure shows a 4x MIMO signal with noise and channel distortion added. Thank you for viewing this online demo for Keithley SignalMeister Waveform Creation Software.